Hi everybody, this is Mr. Ruger, and this is your second installment of your flipped classroom. I know that it's Thursday. Hey, it's a rainy day. It's Rosh Hashanah, so it's the Jewish New Year, but it also is a rainy day, and so you're probably inside. It's cold outside. What better thing to do than to knock out some schoolwork? Because let's face it, Instagram, Twitter, Snapchat, all of that gets boring. So, let's proceed. Today we're going to be taking a look at complex numbers review. The complex number is represented, obviously, as we put up here, by the letter I. We've talked about that guy before, the letter I. And so we know that the I is nothing more than the square root of -1. We can't take the square root of -1. That's where the I comes in, I for imaginary. Now, something fun kind of happens when we square I, though. When you square I, you get the square root of -1 squared, which gives you just I equals -1. That's pretty interesting because we just said that I is imaginary, yet when we square it, we get a real number. Interesting. Moving into recall, as it says over here, but standard form for complex numbers A plus or minus BI. The A is the real part, the BI is the imaginary part. Of course, B is going to be a real number, but when you multiply it by I, which is an imaginary number, it becomes imaginary. So you have a real part and an imaginary part. Graphing these is kind of fun too. We can get into that if you'd like to know, just for fun in class, although some of you, I'm assuming, not much of math is quote-unquote just for fun, but we're hoping to fix that in the coming weeks here. Operations of complex numbers. When we're adding or subtracting, the important thing to remember is that we must combine like terms. Think of these as variables, as x's, y's, z's, g's, f's, h's, r's, q's, p's, and the ever-elusive w. So when we're adding, we just add the real parts together, 7 plus 4, 11, and then we add together the imaginary part, -3 plus 5 gives you +2. Now, I'm going to let you just kind of look over all of this, and you can pause it to kind of fill out the different parts. So that way you can say, oh, okay, rather than trying to go through every single piece of this. We do have something interesting happen. So we have this guy here, and it says, find the values of z squared and z to the third. So we take z and we square it. We should end up with 1/4. This actually gives you plus the square root of 3/2 minus 3/4, which in turn gives you -1/2 plus square root of 3/2. And then when we multiply that -1/2 times the square root of 3/2 by the original z, we should end up with -1/4 plus 9/4i. Take time, look at those, pause it for right now. Actually go through the distributive property, the matrices of all of that, multiply them together, see what you come up with, making sure that what you're looking for is actually the number that you're supposed to get. We can work through one of those problems here in just a minute. But anyway, moving through the process. The conjugate, yes, conjugate. Some folks say conjugate, but conjugate is a word, is a noun, conjugate is a verb. If you're going to conjugate something, you're going to multiply a complex number by its conjugate. Does that make sense? If not, then I wouldn't worry too much about it because it's just mathematical syntax. But the A and the BI are the same. The only difference is that the sign between them changes. It's important that we say between them. Like I've told you guys before, the quantifiers are in the prepositional phrases, and between them is a prepositional phrase. Actually, I think between them changes is a prepositional phrase, but between is definitely a preposition. So, if I'm looking for the conjugate of 4 minus 2i, it's simply going to be 4 plus 2i. That's a negative, so we make it positive. Okay? The conjugate for this guy, once again, this middle sign is a positive, so it changes, but we do not change this one. It is not between them. It is not between them. We do not change it. Only this one. Not this one, only this one. Not this one, only this one. And if the music wasn't playing in the background, you would swear that I was saying something and you were missing it. So someone over here is freaking out because you thought that I actually messed up the audio. Next thing, exercise 6 and 7. It says to multiply or simplify. When we simplify, we cannot have imaginary numbers in the denominator. Much like we can't have square roots in the denominator, we have to rationalize. Here, we have to multiply by the top and bottom by the mathematical or complex conjugate. So we have to conjugate. We're going to take the conjugate of both of them. So we multiply top and bottom by the conjugate, which is 3 plus I, 3 plus I, because we changed the sign. We do that, we should end up with 6 plus 2I over 10. Over here, we have, once again, we're multiplying the top and bottom by the conjugate of the bottom. We should end up with 7 plus 17I over 13. Now what I'd like to do is actually walk you through one of these processes. So I'm going to stop, and then the next time that I play this, you guys will have the process worked out. Okay? And hopefully you guys are working this out at home. You're looking at it going, whoa, that thing just got really close. What are we doing when it gets that close? But let's see if we can do some visualization for this. Okay. Let's back this back up a little bit. Okay. Here you go. That took all of about a few seconds, but not too bad. When we're doing this, we're going to end up with, we have the two boxes, the two area models, the two Fuquays, the two distributive property visual representations, if you will, of multiplying polynomials. You call it whatever you want, but it is what it is. It is a representation of the distributive property, the double distributive property. So I have the denominator on the right side multiplied by the denominator, and the numerators are on the left side. So let's start with the right side real quick, which is the conjugate.